Good day, everyone. First of all, let me introduce myself. My name is Marilyn Essa. I'm the first presenter for this presentation. I will be presenting the introduction and theoretical background of this study. In this experiment, Vortex free and forced vortex model FM24 was used to measure and produce the elements of free and forced vortices, as shown in the next image. There are three objectives that we need to achieve in this experiment. The first one is to investigate the physical phenomena associated with free and forced vortex. Second one is to study the surface profile of free vortex and its relation with the velocity. And the third one is to study the surface profile of forced vortex and its relation with angular velocity. Fluid dynamics. Vortex is a region which fluid mass is revolved around axis line or in spinning motion, usually curved or straight line. Next to the axis, the vortex velocity is maximum and inversely decreases with radius. True for different orifices, the orifice remove accessories that allow full analysis of the flow over a flow rate range. In real industry, this vortex flow applied in design of turbine, natural phenomena, and creating safety features against natural disaster. There are two types of vortices, which are free vortex flow and forced vortex flow. As shown in the figure below, the left side is the free vortex and the right side is the forced vortex. Free vortex form when water flows out of vessel through central hole of tank base where the rotation degree depends on initial disturbance. In free vortex flow, there are no energy interactivity between external source and the flow. The rotation caused either by internal action or some rotation imported before. The fluid mass rotates due to conservation of angular momentum. During this experiment, the free vortex is created using rotating plate. Figure 2 shows the free vortex of tangential velocity inversely proportional to radius. These are the examples of the free vortex flow. Figure 2 shows the Whirlpool River. Figure 3 shows the water flows out of the bathtub or the sink. Figure 4 shows the flow around the circular bend in pipe. And the last figure shows the flow in the centrifugal pump casing. Free vortex behavior usually shows large Reynolds number of flows until fluid viscosity becomes very small and neglected. As shown in figure 6, the velocity inversely proportional to the radius. The characteristic of free vortex in ideal fluid is that it does not require the application of external energy or any other addition or destruction of energy in the flow field. For these cases, the presence of friction would make it impossible to create or destroy the vortex motion. The motion in the fluid might be permanent flow pattern and the velocity of the fluid will be constant with time. In the non-technical terms, the fluid near the vortex center will circulate faster. At the same time, the inner streamline has shorter distance to travel to complete the ring. Hence, the Bernoulli equation is applied. Based on the vortex profile for all diameter of orifice and gradient of the graph can be calculated using the equation below, which are theta h is equal to h minus h naught is equal to w square r square over 2g, where h is the initial non-rotating surface height of the fluid, h naught is the height of the axis, w is the angular velocity or the radian, r is the radius of the cylinder, and g is the gravitational acceleration. Vortex caused by the external forces on the fluid, such as the impeller of a pump. Figure 7 shows the first vortex of tangential velocity directly proportional to the radius. Throughout this experiment, rotating plate with the addition of pedal created the forced vortex flow. At the center, the forced vortex is 0 and keep on increases proportionally to the distance measured from the center. Both forced and free vortex release minimum pressure at the center. Moreover, forced vortex has higher minimum pressure compared to the free vortex. During forced vortex motion, the fluid mass rotates by external source power that exerts constant torque on fluid mass and causes it to rotate with constant angular velocity. For example, rotating a vessel containing a liquid with constant angular velocity as shown in the figure below. For forced vortex, the surface profile is parabolic, as shown in the figure below. Forced vortex behaviors such as vortex core usually show low Reynolds number of flows. The velocity will increase with increasing radius, as shown in the picture below also. Next, I will pass the presentation to my friend.
Next, let's move on to the apparatus and procedures. So this is the apparatus for the experiment. At the top of the equipment, we have surface profile, next outlet valve, outlet, pitot tube, orifice, pedal, bridge, profile measuring gauge, 9 mm diameter, nozzle, 3-way inlet valve, 12.5 mm diameter nozzle, and lastly, the inlet. So for the next slide, this is the figure for both free and forced vortex. In the free vortex, it consists of profile measuring gauge, orifice, and also pitot tube. Pitot tube is a device to measure flow rate. And next is forced vortex. It consists of pedal and also surface probe. So for the general startup procedures, first, the study bench was placed on the hydraulic bench. Second, the inlet and outlet hose was set up. Third, the stand of the equipment was adjusted to reach the horizontal positions. Next, general shutdown procedures. First, the valve were closed and the pump was switched off. Second, the orifice, pedal, and other accessories were removed from the cylindrical vessel. So this is the procedures that has been set up for experiment 1, which is free vortex. The steps were as shown in the slide, and lastly the steps 3 until 8 was repeated for another 2 orifices with a diameter of 16 mm and 24 mm. Next is procedures for experiment 2, which is forced vortex. The step actions in the slides, and lastly on step 4 until 8 were repeated with different volumetric flow rates.
Assalamualaikum Dr. Zaki and Madam Rani. My name is Hafizal Azmi bin Ahmad, and I'll be presenting on the discussion and result part. So the first one is free vortex. Free vortex, as we know, rotates without external force. So in this experiment, different size of orifice was used, and ours is 8 millimeter, 16 millimeter, and 24 millimeter in diameter. And based on the result, all the orifice shows a trend where the velocity increases as the radius decreases, while the pressure head versus 1 over r square shows an increasing trend as the diameter of the orifice decrease. For the graph of velocity against radius, both the orifice of size 16 millimeter and 24 millimeter shows the theoretical velocity higher than the actual velocity, while for the orifice of size 8 millimeter, the actual velocity is more than the theoretical velocity. So for the next 6 slide, that is the result that we get, and that has been calculated for the free vortex. For the next part, which is the force vortex, vortex rotates by a constant torque exerted by some external source onto the fluid mass. For this experiment, which use a pedal at the bottom of the tank to create the force vortex. From the data that has been calculated, we can see that all of the experiment run shows the value of the measured deviates from the theoretical with only small differences. The height from the top of measuring gauge to bridge h increases as the angular velocity increases. So for these next two slides, it shows the result and the graph that we obtained from the calculation of the force vortex for the first run, second run, and the third run.
So this is the conclusion section for the experiments. So for the conclusion in experiment 1, as the radius of the orifice increases, the velocity decreases, and a bigger orifice diameter will yield greater vortex. Next, the product between velocity and radius is not constant as it's supposed to be due to the human error. For the experiment 2, as the angular velocity increases, the height from top of the measuring gauge to bridge also increases. The slope of the curve increases as angular velocity increases due to the stream function formed in the force vortex is parabolic in nature. So to sum it all of the objective has been achieved in these experiments.
There are 6 recommendations for this experiment. Firstly, make sure all the general start-up procedure and shutdown procedure are properly managed to prevent any error during the experiment. Secondly, when the measurement is started to be taken, the flow and water level must be stable so the data can be obtained accurately. Third one, the center of line must be accurate to avoid any error. Then the available range of diameter of orifices should be expanded to have more accurate results. Other than that, the experiment can be repeated several times or at least more than once to get more accurate data. Lastly, all the equipment must be handled cautiously to prevent any harm during the experiment.